Okay. When you multiply polynomials, you guys have seen these before, but if you had two binomials that are multiplied together, what method did you use to expand these into polynomial form from the factored form? Distributive property, which for binomials is often, this is the distributive property, but when you distribute the 3x times the x, and then the 3x times the 1, then negative 2 times the x, then negative 2 times the 1. What's the acronym for that process? FOIL, because you're using the first terms, then the outer terms, then the inner terms, and then the last terms. So what we're going to do at first is just the FOIL method, which is just the distributive property. And so if you apply that method, 3x times x is a 3x squared. Your outers, 3x plus 1, is 3x. Your inners, negative 2x, or negative 2 times x. Now, it's up to you whether you want to identify these horizontally or vertically. To me, it's always easiest to stack like terms vertically to give a visual reminder of combining like terms. Then we get to the last term, negative 2 times a positive 1 is a negative 2. And when you combine all of these, it gives your final polynomial form, 3x squared plus x minus 2. So this would be considered the expanded form of those factors. Okay, so once again, what you did there was you multiplied the first, then the outers, and then the inners, and then the last terms. Okay. Now, this works for non-binomials as well. It's not called FOIL for non-binomials. It's just called the distributive property. And so if you took 3x minus 2 times x squared minus 2x plus 1. So if we looked at this example here, the process would involve distributing, but now it's not going to fit the FOIL format, although the methodology is the same. So first terms, 3x times x squared gives you 3x cubed, and then just distribute that and continue. 3x times a negative 2x, negative 6x squared, and then the last set, 3x times a 1 is plus a 3x. And now you can move to your next term, in this case, negative 2 times x squared, negative 2x squared, negative 2 times a negative 2x, becomes a positive 4x, and then negative 2 times a 1, negative 2. And once again, by stacking these vertically with like terms, it may just allow you to simplify it a little bit more easily because you can just visually combine down the columns. And when you combine down the columns, you get your final polynomial form for your solution. All right, if I was asking you what is the degree of this expression here, what would the degree be? So this is second degree. And how many terms is there in this polynomial? 3 terms, so that's called a trinomial. And in this one, what is the degree of this expression? Highest power, third degree. And there's 4 terms, so we don't have a specific name for that, so it would just be polynomial. Right. I want you just to take a moment or two on page 23. All right, any questions on those? Sounds like you guys all agreed with one another. All right, really quickly, the answers to these. We'll confirm them with a calculator, just so you know how to use your calculator. Okay. If this happens to be a problem that you want to verify with your final 15 minutes of calculator time, you can do that. If we just type in the expression 2x minus 1 times 1 minus 2x and hit enter, it puts it automatically into factored form. So your calculator is going to automatically factor the answers. Okay, but this isn't what you want to do. This is the next thing that we'll talk about in this chapter. But you want to expand it out and write it as a polynomial. The way that you do that is you have to use that command, expand. So the expand command is located in this algebra tab, F2. And so if, before you write this product, if you go to F2 and hit expand, which is number 3 here, it is going to have grouping symbols, so you have to put those factors or that product inside of another set of grouping symbols. Okay, but then if you just type it exactly as it appears, hit enter, it'll confirm the answer for you. So negative 4x squared plus 4x minus 1. Is your solution. And again, from listening to you guys, it sounds like that's what almost everybody got anyway. All right, see if you can use your calculator to confirm your answer for B. Or?
I was just wondering, is it necessary?
All right, so if you type this in, once again, we start with expand. Type our product exactly as it is. 1 minus 2x minus 3x squared, all times 3 plus x. Close off the whole expansion. And you get your answer of negative 3x cubed minus 11x squared minus 5x plus 3. All right, now, the question was asked, is this the same as if we took a negative out of every single term? Are those equivalent? Does everybody see what we did to get to that bottom level? Okay. Now, here's where these two are different, the way they look here. In order to make them the same, that negative that you took out of each term still needs to be accounted for. So it would have to be out in front. Okay. When you're looking at this, when you're looking at this, when it asks you to expand it or write as a polynomial, it means no multiplying or factoring in this case. Now a negative is being factored, so you would need to distribute it back to get up to this form. So this is the polynomial form up here. Now here's the place where this can be used. If this was part of an equation, so if we took this expression right here, if we took the negative 3x cubed minus 11x squared minus 5x plus 3, and it was part of an equation, set equal to 0. Now, could we turn this left side into this? Yeah, and really what we would be doing is multiplying both sides of the equation by a 0. So you could get an equivalent equation that says this, because you'd simply multiply every single term in the entire equation, left and right of the equal sign, by negative. And so that's where that concept comes into play when we're solving equations. Okay?